All right, welcome all, and this is our third part of the series for our disinfection solutions and beverage production. So welcome to this as the third of our four-part series, and thank you all for joining, especially those who have joined some of the other sessions. For those, I hope you were able to join them, and if not, there are recordings available on our website, evoqua.com. So do tune into also our fourth installment of this in March. And so today we will be learning about ozone practices and sharing our practical insights on effective disinfection, sanitization, and reuse methods. We will focus on how ozone can be so impactful in various applications in beverage facilities, and even highlight some great sustainable solutions we have seen with ozone applications. Then we will close out with an exciting panel discussion, followed by questions and answers with some of our ozone and beverage experts. Today's session is recorded, and so it will be available to you and your colleagues at a later date. So a great place to start here is with the fundamentals. Why do we need to disinfect in a beverage facility? Well, as those in the beverage industry know, water quality and compliance are key. Waterborne microorganisms are responsible for adverse effects that can cause production downtime, negatively impact the products, and worse, can be a health risk to consumers. Ozone disinfection is effective with very low residual levels and provides strong treatment solutions with an impressive safety record. Inline validations are simplified and are easier to achieve by the known performance, which in turn results in operating confidence. To overcome the challenges in a beverage processing plant, high quality, reliable disinfection systems that makes their process repeatable are critical. Facilities can not have a value outside of the regulatory ranges, as these hits jeopardize their product and pose a risk to health and safety of the consumers. New regulations are driving precision in the final safety and quality steps before bottling. When reliability is limited, easy and quick maintenance is not possible, which drives up costs and creates more risk. There is a constant pressure in facilities to prevent downtime and increase uptime to ultimately maximize their profits. With this, there is the challenge of how can they effectively gain feedback on their process and reliably validate this for reporting without compromising the time of the operators. Also, how can they balance the cost to operate by establishing a process that has less downtime to disinfect, more uptime to produce the product, and thus increasing line utilization, optimization, labor, and material costs. For these facilities, what it really comes down to is a desire to focus on production of their product only and not have to handle or solve the disinfection and sanitization needs. So now we'll have our first poll of this webinar. Let me have that brought up. So the poll here is, please identify which areas of the beverage production have you utilized ozone in? And multiple answers are allowed here. So I'll give you guys a few seconds here to complete the poll. All right, I'm seeing some results coming in. All right, I'll go ahead and close the poll here and share the results with all. So pretty split in a few of the different areas where we're seeing this. So definitely value in the different applications that we'll talk about later on in this webinar. So again, as we were just talking about of the I'll have the poll. As we were talking about the challenges we're seeing, you could guess that disinfection really can be then the solution to these challenges. At Evoqua, the different disinfection technologies that we have, our ozone systems UV, OSEC, analyzers and controllers, gas feed systems, and chlorine dioxide generation equipment, and more. And again, today we're focusing on the exciting topic of ozone disinfection. So ozone is the triatomic oxygen, and as such, it is a highly reactive product of energy disrupting the oxygen molecules. Ozone has a short half-life and decomposes back to oxygen, which can make it extremely impactful in these beverage applications. As seen here on the chart, ozone is one of the most powerful commercially available oxidants. And as a disinfectant, ozone can kill bacteria, viruses, molds, and parasites, and is highly effective against common foodborne pathogens. With this, when used in the right applications, ozone can provide significant sustainability improvements to the facility. We have seen and echoed by operator feedback in our experience how successful ozone applications can be. Throughout this presentation, we will see how ozone has the ability to reduce annual water consumption, in some instances more than you even thought possible. Even though the core elements of on-site ozone generation are air and electricity, best practices with ozone can actually help reduce the power consumption at your facility compared to some of the more traditional methods of disinfection. With the quality improvements and increased reliability, ozone-based applications can see a reduction of annual process downtime, allowing you to produce more and be more efficient. The simplified designs of ozone systems, especially the packaged ozone generation systems, can minimize maintenance, allowing your team to focus on your products and not worry about your disinfection needs. And last, but maybe most important, is the quality of your product will not be compromised with ozone, but on the contrary, we've actually seen great success with customers who have reduced or eliminated their microbial hits and have been able to distribute and sell more of their product without compromising their quality when they've used ozone in their facilities. For most beverage facilities, there's a growing need for sustainability. For these facilities, they can leverage the use of ozone to reduce water consumption compared to heat-based treatments or chemical-based treatments. As seen here, for annual water consumption in this facility, when using a 5-step CIP ozone process, you can reduce annual water usage by 20% compared to chemical sanitization, or even more, 25% compared to hot water sanitization. When then using a 1-step CIP process with ozone, this allows the customer or user to reuse their water source, and they can reduce the annual consumption of their CIP processes by 93% compared to chemical sanitization, or even 94% compared to hot water sanitization. Now, these calculations are based on a 4-cycle CIP process and may vary facility to facility. But what's really important is here, when you're looking at a multi-cycle process, the ability to reuse the water, which can be achieved with ozone, can significantly reduce water consumption. Beyond water consumption reduction and aligning with the core needs of beverage facilities, ozone can also provide sustainability by reducing or even eliminating loss of product due to quality. One facility informed me that they actually reduced their average monthly product discard of about 400,000 tons to no discard, and have sustained that over the last 18 months since they've implemented ozone equipment into their facility. For each beverage facility, these diagrams will certainly differ, but this process map is to give a view of where the disinfected water can be used within the process. If chloramines are present, different processes are used and care should be given to that in their design. Ozone can be used in many ways in the beverage industry for disinfection against microorganisms. These can include water intake and processed water, product water production, disinfection of the process equipment to prevent spread and contamination, surface cleaning and disinfection, including disinfection of the bottles, especially reusable bottles in the wash prior to bottling, disinfection of the wetted parts of the water bottling equipment and machinery, disinfection of the surface of the bottles and sealed cap of the bottled water, and disinfection against airborne microorganisms that may be present in the air above the water bottles. So now we'll move into our second poll. So very similar to the first one here. We're now looking at kind of the future state. So please identify which areas of production you anticipate ozone being used in the future. All right, starting to see some responses coming in. And again, multiple answers are allowed here. All right, give a few more seconds. Still seeing some responses coming in, which is great. All right, go ahead and wrap up the poll and share the results here. So it looks like we're going to be seeing a lot more people interested in surface and equipment sanitization and in water reuse in the future, which is very exciting. So go ahead and hide that. All right. So with that, we're going to start to walk through some of the applications that we see ozone being used in the beverage facilities. So first here with water intake and processed water. So as we know, water is part of the product, if not the product itself, and water is used for several steps in the production of cleaning. For many facilities, a key to sustainability is using non-potable water to reduce the demand on local municipalities. Therefore, this processed water must be free of pathogens or impurities that could risk human health or product spoilage as it comes into the facility. There is also an increasing need for process and product water to be treated to higher standards with additional unit processes to increase production cycles achievable before cleaning. Spent processed water is increasingly seen as an opportunity for point source reuse or to be used elsewhere in non-beverage contact applications such as washdown or CIP. Wastewater reuse is growing in popularity as a source of utility water makeup, further reducing the freshwater needs of the facility. With all of this, the challenges of disinfecting the water are critical to the operations of the facility so that they can meet their production goals. With this, we see customers looking for solutions that are simplified and improve production uptime with less maintenance. They're also looking for solutions to automate the processes and ensure reliability in the facility while providing this sustainable solution. With these needs in mind, Evoco was able to provide one complete and self-contained package generator system to a bottled water filling process in California. This delivered a safe, tested, and qualified solution offering verifiable results via real-time monitoring of concentration. This solution offered key safety by keeping ozone off-gas below the minimum levels while still maintaining the HACCP regulations for bottled water. This was achieved with the trouble-free approach of the package generator system. When leveraging ozone disinfection, it is important to dose the right amount of ozone for sustainability, quality, and safety. This can be achieved with real-time monitoring of the treated water by utilizing an integrated control logic to chase the desired residual set point. With ozone being generated on-site, it can reduce the production downtime as you can ensure you have the level of disinfection when you need it, creating the reliable solution. This simplified solution helped improve the customer's efficiency, driven by their sustainability goals, and with a short-term return on their investment. Another application here is clean in place, also known as CIP. This is the method for cleaning the interior surfaces of pipes, vessels, and process equipment without disassembly. The washing process traditionally consists of several cycles in which detergents, caustic, acid, and rinsing materials are recycled through the process equipment via an automated system of tanks, valves, pumps, and heat exchangers, all managed by a programmable controller. So again, there's a lot that typically goes into these applications to really help drive the reduction of labor and the disassembly of the equipment to still provide the disinfection. Now, while conventional chemical CIP significantly reduces the time and cost of system sanitization compared to the manual cleaning, elevated temperatures in chemical detergents are often required for complete effectiveness. As a result, significant amounts of energy, water, and chemicals are consumed in traditional chemical CIP processes. Solutions, therefore, need to prevent the spread and contamination and reduce the risk of microbial growth in product water or even the potential of recalls, which are becoming more and more prevalent nowadays. The consumers here and users are also looking for solutions that are sustainable and environmentally friendly, where the runoff water is extremely clean but can still provide overall plant sanitization by reducing overall microbial load. So with that, we look at an example here with an ozone injected water can improve the effectiveness of CIP because it is very powerful, with ozone being a very powerful oxidant and works well at reduced temperatures. Conventional high temperature CIP processes require significant energy and time to ramp the entire system up to the target temperatures and then cool down at the end of the process. Ozone injected water can replace chlorinated sanitizers, peracetic acid, and hot water rinse in traditional CIP protocols. When ozone replaces chlorine, hot water, and steam, it can save energy and reduce the carbon footprint. It reduces the chemical usage and challenges associated with the disposal of these chemicals, and it can reduce the storage risk, because the ozone is being generated on demand. This can result in a solution that can be 20 to 85% less expensive than hot water sanitization based on the weekly needs of the facility. In addition, the use of ozone can significantly reduce downtime via the length of the time out of service, even with a CIP process. So looking at the CIP processes kind of from a traditional standpoint, for hot water use, the process can be about 3 to 6 hours of downtime. For chemical and process, this downtime can be 2 to 4 hours of contact time, but overall, sometimes more than 12 hours of total time. For ozone, though, the process can be 20 minutes to 2 hours, so significantly lower than the other processes here. So when we think about that, then ozone can help reduce the process time due to service by 67% compared to hot water rinse and by 83% compared to chemical, which can allow, again, the team to really focus on what they want to be working on for their operations. Ozone is more powerful in cold water and thus reduces the need for hot water and steam. This approach, again, can conserve water, reduce the rinsing and chemical requirements, and ultimately provides the opportunity to reclaim the wastewater. As shown earlier, all these attributes can be enhanced when reducing the number of stages in the CIP process. But in addition to the operational savings and positive environmental impacts, as seen over here on the right, ozone CIP can also help reduce microbial hits, even with the reduced number of stages in the process. So you can see here on this chart, and the light blue is using the more traditional method with a 5-stage CIP, but then compared that to a 3-stage CIP in that same facility, it significantly reduced the number of microbial hits in this facility. And this is really impactful, as you are able to improve the quality of your process and ultimately the product, which can lead to even more savings for your facility. And then the last application here is in surface cleaning and disinfectant. So surface cleaning and disinfection is a critical part of meeting the quality and regulatory needs of a facility. Today, many plants depend on chemicals to achieve these values, which can be costly and have many other impacts on downstream applications. Thus, we see customers in this market looking for alternative solutions that leave no residual, which ozone does with its short half-life, while still producing the disinfection to ensure the quality of the product. The desired solutions here are very similar to those that we just talked about in the clean in place process, but it's really important to think of this part of the process separately, because the microbial hits on the surface of the process can have just as much of a negative impact as a hit on a process line. So when thinking about disinfection in your facility, it is really important to think about all the places where disinfection should and can be used to help reduce microbial hits. So when using the ozone generation system versus a traditional foam process, we can actually see some clear savings in the water and time for that application. So at one of our sites, the customer was looking to replace their surface disinfection process for their 4 fillers. The incumbent foam process required 2 rinses at about 1,300 liters per rinse and at 3 different passes. When then we switched it over to our ozone-based application, that process required only 1 pass at about 1,900 liters. Also comparing them from a labor perspective, the foam process's 3 passes required 7, 8, and then 7 minutes of cleaning, while the ozone process only required 1 pass at 10 minutes, which again was applied over the 4 filters or fillers. The net here was that the customer was able to save over 3,000 liters and 48 minutes of labor with each filler cleaning cycle. So you can start to then think about over the course of the year how much that will add up in sustainability efforts, cost reduction, and labor reduction, allowing the team to focus again on what's most important in their facility. And another key account customer of ours, we were able to monitor a continuous 24/7 low concentration ozone regimen with periodic high concentrations. This approach provided significant operational improvements, including clear ROI to heat-based treatments, thus demonstrating how sustainable ozone applications can be by reducing water consumption and energy costs. As seen in the chart to the bottom right, low concentrations, which can easily be provided and maintained with Evoqua's specific ozone technology, can provide a powerful disinfection to prevent growth that leads to challenges, resulting in downtime. Thus, ozone can save even more money by providing a factory with more uptime for their core processes. So you may ask, where can I apply ozone? Well, it can be on the belts, the nozzles, the fillers, the bottle and cap washing, all ones we've been talking about here. But it's better to really think of it this way. Ozone can be used any place where you may be getting microbial hits or have risk of getting microbial hits. And in that regard, you can really start to think about how you can improve the overall quality and performance of your facility by leveraging ozone. With Evoqua's Pacific Ozone Solutions, there are 4 core values that our product delivers: safety and control, measurable results, sustainability, and a simplified operation. When it comes to safety and control, we at Evoqua always strive to deliver. This is a core pillar of our company and has been proven in industry with ozone-based solutions. On-site ozone generation allows the generation of a powerful disinfection without having to handle chemicals, which can improve safety in almost all facilities. Our technology provides measurable results that can and have been verified and validated, allowing for repeatable processes when it matters most. Ozone disinfection can deliver known results time after time with minimal effort to the operational process. Our ozone systems offer a sustainable solution, allowing you to reduce costs associated with maintenance, improve production by increasing uptime, all with a simple to use product that minimizes the resources needed to generate ozone. Last, the Evoqua's portfolio is engineered to provide full monitoring to meet even the strictest operational requirements and can seamlessly configure to almost any application. In short, we offer simple, proven ozone technology. So with that being said, now we're going to move into the panel discussion. And I'm pleased to introduce our esteemed ozone and beverage experts with Don Lanini, Jackie Schramm, and Sueli Bacchus-Roll. So as we're going through these 2 questions here, I do encourage you all to start posting some questions into the chat box here, because after we go through these 2 questions, we'll open up to a broader question and answer session with these experts. So at this time, I'll invite the expert panel here to come on camera, and then we can go through with the first question. So I'll bring the first question up here of, what considerations should producers take to ensure disinfection requirements are met where safety and quality are critical? So Jackie, if you could start us off here.
Yeah, I can definitely start you off. Some of it you touched on in your presentation. It really all starts with the air prep, what the feed gas is going to be into the ozone system. So we want to make sure we have clean, dry, compressed air or oxygen that we're sending into the ozone generating cell. Then we generate the ozone in the ozone generating cell. And the next piece is the mass transfer system. You really want to make sure that that mass transfer system is efficiently dissolving the ozone gas so that you're getting it to the application point. Once you get everything dissolved into the gas and out to the application, there's some other technology built into our machine, which Don will go into.
Thank you, Jackie. Yes, control and monitoring, the fourth key element to a successful ozone package, really to help you, meet your and confirm your control points and meet your HACCP requirements. Really looking at how you want to capture this information and log this information along with your typical best practices for quality control. It's just another component that you really need to maintain and watch it as you're, operating your ozone equipment.
For the dissolved ozone that was not the ozone gas that was not dissolved, I think there is also a lot of safety equipment which you include for destroying ozone, isn't it?
So off-gassing, yes.
Yeah.
Depending on your application and how you're controlling your mass transfer of the gas into the water, you're going to have some off-gassing because not all of it's going to be dissolved. And managing that via decomposers is the best practice. Typically, we look at integrating a catalytic design. The ozone gas comes in contact with a catalyst and it generates an exothermic reaction that generates heat and converts that ozone gas back to oxygen. There is a thermal device also out there by other manufacturers, a little more complicated, not as safe in our opinion, but those two devices are typically integrated on, some aspect of your tank's ventilation system.
Great.
And in addition to that, we built in safety analyzers into the system, not only at the ozone generator, but at any usage points out in the facility.
Yeah, that's great. I appreciate the insightful answers there. So moving on then to the second question here. So how is ozone enabling water optimization? So we'll start with you again here, Jackie.
Yeah, sure. So there are several opportunities in a beverage plant for water reuse, utilizing an ozone system. One of the biggest was touched upon in your presentation. That's the single-step CIP process. In that process, all of the water that's being used is being recycled back to the beginning of the process for reuse. In addition to that, our reject water, additional wastewater applications, for the water to be sent to utilities are also opportunities in a beverage plant. Sueli, do you have anything to add?
Oh, yes, sure. A very good point, Jackie, on the utilities, because there are many factories here which are, for example, accumulating the return of the rinser or the return of the cap disinfection system together with the CIP water separately and treating this water with ozone and being perfectly distributed again for all the utilities in the factory, because this water being treated with ozone is free from bacteria or other microbiological contamination. It's a really effective sanitizer. And if there are points where you don't want to have eventually residual of ozone water is most probably in 20 minutes over, you can still use a UV system on more critical points. So you can disconnect your ozone dissolved in the water through a UV system.
I do see a question in the question section, and maybe I should have expanded a little bit further on that fourth component of a successful ozone system, and the devices used to measure, monitor, and control the ozone generator. Most commonly found, or most typical for the beverage industry, is a dissolved ozone analyzer, and that's an ampermetric technology, and there's multiple manufacturers out there that offer this device. And we take this ampermetric probe, measure very close to a control point, and we take that analyzer's information back to a PID controller to adjust ozone delivery to that contact tank or to the point of use. You know, some of the common manufacturers out there, ATI, Rosemont, Hawk, Mettler Toledo, and multiple others that offer this technology. We even have a product that we offer to monitor and measure dissolved ozone concentrations. It is also an ampermetric technology. And I don't, you might find some that use oxidation reduction potential, but it's not really, in my opinion, not really as accurate. It's more of a reference that you're seeing an oxidant in your water. Hopefully that answered that question.
Yeah, that was great, Don. So yeah, those were the two kind of main questions we were going at. So we'll now open up kind of into the question and answer session, which Don, you've already jumped in, which is great. And so one of the questions coming in here, I think could be great for you, Jackie, is what is the optimal water temperature for ozonated water surface disinfection?
Sure. So ozone dissolution into water is affected by temperature. So the cooler the water, the better. Once you get to about 85 degrees and higher, you're really going to have a very hard time keeping ozone dissolved in water and getting it to the application point. So really anything under 85 degrees is fine, but optimal is going to be in the cooler range.
That's great. Thank you. Another question coming in here. So if UV or ozone are used to disinfect water for bottling, should it be a critical control point in the HACCP? Don, if you don't mind taking that one.
Certainly, in all applications, you're going to have these critical control points that you want to monitor to confirm that you're meeting your disinfection requirements. So yes, typically where you're applying it, and then right before you might be where you're applying the ozone as a disinfectant, and then right before where you might be applying it for your purpose, your use, if it's going into a product or if you're doing some other disinfection step with the dissolved ozone concentration.
Yeah, that's great. Thank you. Another one here is ozone in combination with UV an applicable solution for water reuse in the CIP? Sueli, if you could jump in on that one.
Sure, great. It was, as you showed in your slides, and also in many of the case studies that we have due to our installed base, we see that it's becoming more and more popular, the introduction of ozone in CIP, mainly as Jackie mentioned, on the temperature. You have a huge save when you are doing cold CIP on time, because you don't need to heat it up, the stainless steel, and to cool it down. So you are working around ambient temperature, and this is excellent temperature for ozone to react. And when you are in doubt that you shouldn't have any residue of ozone in your water, then you can cancel it with UV. There are many factories which circulate the ozonated water, and then when it goes to a process point, not only on the CIP, on the process point of use, then to make sure the water is free of ozone at all, then they will add pass of UV to disconnect that ozone. I hope this answers your questions, but feel free to drop us a line. We can go on detail if you have any specific question to this.
Yeah, that was great, Soy. Thank you. So I see a few questions here around what is the right concentration necessary for disinfection in the bottling facilities, and also around maintain the right concentration for safety. So kind of bring a few of those questions together. So I don't know, Don, if you want to start off with that, and maybe others want to jump in. There's a lot to this question.
Certainly, the concentration levels are really going to be determined by your own quality control procedures specific to the product you're producing, and really defined by you. But there are some suggested levels, and it really has to do with concentration and time and contact. So, and depending on the product you're producing, you really want to maybe monitor and measure those things so you can meet the requirement that you're defining for your disinfection requirements. It's most common to see a concentration at 0.1 milligrams per liter for up to 5 minutes in contact time. The range is typically in that 0.1 to 0.4 for that 5 minutes of contact time prior to it going into a package. So, and that's really a guideline that's used for the bottled water world. And then, you need to look at what you may want to do to ensure some of the safeties you need for your specific product. There's some other waters out there that everybody produce that offer some additional challenges, but we really look for what we refer to as this CT value. That's the concentration and time you have it in contact to target any specific microbe that you might be concerned with for your product.
And sometimes you hear also about biofilm. So you can always do a shock, isn't it? Shock disinfection, heating, raising your concentration to 1 ppm for 5 minutes, but not periodically, just as a shock to release any point of contamination which have maybe occurred during the years and generated some biofilm spot.
Wonderful. Yeah. So then another question coming in here, kind of in a similar lens here, but talking about that ozone is destructive in some of its characteristics to certain materials. So I guess the question with this one is around what are the considerations that facilities need to make when using ozone, given its chemical properties.
I can take that one, Ryan.
Wonderful.
So ozone is a non-specific oxidizer. It will oxidize different materials, and therefore materials of construction are definitely a key concern when implementing an ozone system. Ozone dissolved in water tends to not be as corrosive as ozone gas. So in terms of a low level of ozone dissolved in water, it can be applied to many different materials. But in a typical beverage facility, where your materials of construction include stainless steel and high quality O-rings, typically you're not going to have an issue with ozone compatibility.
Yeah, that's great. So another question coming in here of is there any possibility of using ozone for more residual applications? Respectively, how long would it be available in the water. So talking a little bit, I guess, about its half-life, and maybe give a little bit of a high-level overview there. I don't know, Don, if you want to start off there.
Yes, really that's part of that control and monitoring. Really, there is a half-life to ozone that has to be considered. So we look at those things. So we want to dose to make sure we meet a specific concentration for a period of time. Half-life is influenced by water temperature, water quality, such as pH. The higher the temperature, higher the pH, ozone half-life starts to shorten. So you have to manage those variables based on the specific water that you're producing.
Yeah, that's great. Thank you. And then another question kind of coming in here around ozone destruct. Or I guess a few questions around it. So I guess with that, if one of you wants to kick off here, of just kind of give a little bit of just kind of how ozone destruct works into the system, and again a little bit maybe more around designing the right system for optimal control.
As Don mentioned, there are the catalytic destructors, as we also supply them. When you have undissolved ozone, and as Jackie mentioned, to mitigate if there is released ozone on the outside the equipment or on the air, there are the sensors which will give an alarm if a certain level was reached, and they are very low. But how to design and to size the system is dependent on different variants. Or you have something to complete, Don?
No, that sounded good. Yeah, I do see a question in the presentation chat section, and I'm not sure if any of the panel see that. I'm not sure if I'm understanding sediments or if it's a sediment that the question's referring to. But typically, as we pointed out in the presentation, is really the most powerful commercially available oxidizer. And an oxidizer will eventually, given enough time and given enough concentration, can take some microbes in water all the way back to carbon base. Ozone is also used as a microflocculant in a lot of applications. Water pre-treatment to oxidize some of the suspended solids, so you can actually filter some of those things out. So ozone in certain situations can be used to help treat some of the unknown precursors you may want to manage prior to making the final product you want to use your water for.
That was great, Don. Thank you. And I appreciate all the answers from you all, and the great questions from you guys as the audience. I think this has been a great and engaging panel discussion.
Thank you.
So with that being said, again, this has been a good time. So I thank you all for your time and attention here, and again, the great questions. So please do reach out to anyone on this panel if you have any questions, or you do want to learn more. The team is always very open and willing to talk more about ozone. It's an exciting topic for all of us. And also would remind you all, to please do tune in for our 4th installment in March, where we will be talking about selecting a chemical disinfectant to prevent contamination. So I appreciate, again, all the time from everyone today, and hope we can talk to you all again at the next installment. So have a good rest of the day.
Thank you.